Today's lesson is on statistics. Specifically, today students will recognize that a statistical question anticipates variability by successfully completing a Google form. So we need to know what statistics are. Statistics is the science of collecting, organizing, analyzing, and interpreting data. And students are familiar with statistics because anytime you're looking at a graph and you're getting information from that graph, you're interested in the statistics. Here's an example of a double bar graph. And this double bar graph does ask a question at the top. How much more money did the store make selling pants on day 1 than day 2? So we need to be able to look at the graph, understand that the graph has varying data, and then answer the question being asked. So in this case, it wants to know how much more money the store made selling pants on day 1 than day 2. We can see that this key up here shows us that day 1 is white and day 2 is gray. So when we look at the category pants, you can see the white category says 1,308 and the gray category 1,119. And we can simply subtract to find out how much more money they made selling pants on day 1 than day 2. So a lot of times we're interested in statistics, and statistics always is important to me because when I was a young man, as I told you before, I used to collect sports cards and watched a lot of sports, specifically baseball. And so I have a treat for you today. I actually have a pack of baseball cards from 1989. So that means that this pack of cards is over 30 years old. And I'm actually going to open for you right now. We're going to open up that pack of cards and we're going to see. Oh, that's a very old piece of gum right there, folks. Don't chew that gum. All right, and so we're going to go ahead and take a look at some of the players, and you can see that the data varied. Look at that, Nolan Ryan. He's one of the best pitchers ever. All right, and we're going to see we have a variety of players that were in that pack, and we can see statistically, the pack had different players in it. So, it would not be statistical to ask how many cards are in the pack, because every pack has 15 cards in it. But the players you get, now that shows some statistics. Specifically, you can look on the back of sports cards, and I have 2 players from the Cubs here, Ryne Sandberg and Andre Dawson. And back in the late 80s, these guys were superstars. And we're going to look at some statistics on the back of their cards. So specifically, we're going to take a look at their number of home runs that they hit in 1988. And you can see in 1988, Ryne Sandberg hit 19 home runs. And in 1988, Andre Dawson hit 24 home runs. So you can compare the data. But if the question was, how many home runs did a Cub player hit in 1988? That data is different depending on which player you're talking about. You could also ask the question, how many years did a player play in 1988? And you can see in Ryne Sandberg's career, he had played, it looks like 1, 2, 3, 4, 5, 6, 7, 8 years, whereas Andre Dawson had played 13 years. And so that's a statistical question, and we are interested in collecting, organizing, analyzing, and interpreting that data. Okay, so you might say, well, Andre Dawson played more years because he's older. We're interpreting that information. So we're going to be focusing on statistical questions. And a statistical question is one for which you do not expect to get a single answer. So instead, you expect a variety of answers, and you're interested in the distribution and tendencies of those answers. So here's a good example of a statistical question we can all answer. How many letters are in your first name? So as you count the number of letters in your first name, you could give that answer. But keep in mind, your answer may or may not be different than that of your peers. This is a statistical question, and we're interested in the variability of this. If I had collected this data from everyone in your class, everyone would pay attention to who had the shortest name and who had the longest name because they stand out statistically. I bet a lot of you will be interested in who had the most common number of letters. So for example, if you had 6 letters in your name and lots of students in the class had 6 letters in their first name, you might feel kind of special because you all kind of have that in common. So statistics, again, is the science of collecting, organizing, analyzing, and interpreting data. So here's another example of a statistical question. What is the name of your street? Now this is interesting because although I anticipate I get a lot of different answers from a class of students, it is possible some students who live in the same neighborhood would answer with the same answer. And that's okay. Statistics doesn't mean every answer will be different. What it means is we expect to receive different answers. So here's another good example of a statistical question. What did you eat for breakfast? So students could all answer this question, and everyone would have some sort of answer, even if their answer is, I didn't have breakfast. But anyone can answer that question. But again, statistics is the science of collecting, organizing, analyzing, and interpreting the data. So if I look at some made-up data, if I had asked students what they'd had for breakfast, and you could see that data varied significantly. I have a lot of students who had cereal for breakfast. I had a lot of students who had no breakfast. A couple had eggs, one had pancakes, two had toast, one had oatmeal, and one had fruit. These answers vary, which is what we expected. This was a statistical question. We did not expect to get all the same answer. Now, we also are going to analyze this. We're going to see a lot of students had no breakfast at all. Maybe they're getting up so late in the morning that they're starting with lunch. Or maybe you'll see that cereal is very popular. That makes a lot of sense. Cereal is a well-balanced breakfast, and a lot of you probably have that to start your day. Now, here's an example of a question that is not a statistical question. This is not a question that's statistical because it says, how many stripes are on the U.S. flag? And we all know that the number of stripes on the U.S. flag is there's only one correct answer, that there are 13 stripes on the U.S. flag. And so we want to recognize that we wouldn't expect to get different answers unless people just didn't know. So I've got an example of the data. This wouldn't be very interesting. You can see one person chose 15, and everybody else had the correct answer of 13. So statistically, this isn't really that interesting because we expected most people would know 13 was the correct answer, and then we would expect maybe one or two people wouldn't know the correct answer. Finally, this is not a statistical question. What is the address of Hamilton Middle School? See, ladies and gentlemen, you can't know this. You either know this answer or you don't know the answer. But it's not statistical because there's only one correct answer. And so if you wanted to mail a letter to Hamilton Middle School, what would that address be? And by the way, that address is 75 North Liberty Street. And I want you to make sure you're paying attention because in our Google form today, one of the questions I'm going to ask is, what is the address of Hamilton Middle School? And any student who doesn't select 75 North Liberty Street is indicating to me that they're not watching the video. So thank you for proving your worth here, and keep up the good work, and I'll talk to you soon.